YAML. YAML ain't markup language. The markup language used to define assets. Actor. Any object used in the game. Rules. YAML data related to how an actor functions. Sequences. The YAML data related to the graphics of an actor and its animations. Weapons. YAML data defining armaments of actors. AI. Artificial intelligence. Defines behavior of bots/computer-controlled players. Bits. Folders containing graphical/audio elements. Tile sets. Defines YAMLs of terrain chunks. Maps. Contains YAMLs of playable maps. Every actor, typically buildings and units, needs its definitions and rules and sequences. Sequences are zero-indexed, meaning they always start with 0. Infantry sequences typically consist of stand, run, shoot, die, and icon definitions. Each of these definitions can contain the following. Start defines what image index to start the animation on. Length defines length of animation per facing. Facings defines how many directions an actor faces. Commonly used facings are 1, 2, 4, 8, 16, 32, or 64. A negative facing can be used for clockwise sprites. Tick defines how fast an animation will play. Bigger numbers will be slower. At normal game speed, 25 ticks is 1 second. Each tick is 40 milliseconds. Sequences for buildings consist of idle, damaged idle, dead, make, and icon. Sequences for vehicles consist of idle, turret, muzzle, and icon. Turret is only needed if the vehicle is turreted, and muzzle is optional, shows muzzle flash. These sequence names are not required, but standard among OpenRA mods. However, if custom names are used to define sequences, they must be specified in rules. .png sheets require @extension false to not be treated as .ships. The .png will also need to be defined for each sequence part. @extension false can be defined into false, therefore applying to every definition. These two sequence definitions are equivalent. Defaults are similar to inheriting in that a default value can be overwritten further down the definition. A single definition can be changed to overwrite the default value. Traits can accomplish many different tasks. A reference for traits is available in the description. The trait documentation will tell you which aspects of a trait can be modified. In the following section, we will cover common traits that are used throughout OpenRA. Rules for actors consist of a multitude of different components. At the top of an actor's rule section are inherited traits. These traits allow for basic functionality to easily be added. You can use the inheritance function to easily override, merge, or add data from other sources. Use syntax inherits, inherited_actor. The caret symbol is used to indicate an actor that is used just for inheriting. A prefix symbol is optional but helps to make inheritables easier to see. Any symbol can be used, but the caret symbol is common among OpenRA modders. Building defines a few key properties important to structures. Footprint defines which tiles are occupied or free that a structure occupies. Any X specifies a cell as being occupied, while an equal sign specifies it being open. Dimensions define the size of a footprint in rows and row width. A 2x3 building footprint consists of 2 rows of XX and a final row of equal sign. Leaving cells open is crucial for allowing units to move freely through a full base. Leaving cells open is also crucial for exit points, allowing production buildings to release produced actors. There are 5 possible values for a cell. Underscore equals completely empty. Lowercase x equals blocked, occupied. Uppercase X equals blocked and not counting as targetable, occupied, untargetable. Equal sign equals passable and units can stop on this cell, occupied, passable. And plus sign equals passable, but units cannot stop on this cell, occupied, passable, transit only. HP is defined as health. Most units and buildings have health in the thousands, typically starting at 10,000 or above. Power defines how much power a unit or structure creates or consumes. A positive number increases available power. Negative consumes it. Reveals Shroud defines how much line of sight this actor will have. A cell is 1024 WDUs, world distance units. 1C512 is one cell and 512 WDUs, or half a cell. Hit shape defines the hitbox that the actor uses to receive damage. This is defined from the center of the actor. Using type rectangle allows you to define the top left and bottom right of the hitbox. These numbers are calculated considering the size of tiles, each tile being 1024 units. For a single tile actor like a silo, the hitbox definition is as follows. Top left, x minus 512, y minus 512. Bottom right, x 512, y 512. When debugging in game, you can use the Show Combat Geometry option to visualize the hit shape you define. Armament, weapon, defines what weapon an actor has. Weapons are defined in rule YAML files in the Weapons folder. These have the following notable traits, details, and description. Reload delay specifies how many ticks there are between firing. 25 ticks equals 1 second on normal speed. Range, defined in cells and world distance units. Report. This defines what sound effects will be played when firing this weapon. Projectile. Determines which projectile type to use. Warheads allow you to define the damage done and what action happens upon projectile hit. Spread is used for area of effect. Damage can be customized to do different amounts against different armor types in the Versus section. Wood 50 will make the weapon deal 50% damage to an actor with wood armor. None 150 would result in 150% damage to actors with none armor. Light 40, 40% damage, etc. Production queues allow actors to create buildings or units. At the same time, a valid queue must be defined for each unit. In the buildable section, you can define a queue. Building.gdi will make that actor build from the GDI farmyard. Spawn actors on cell determines what actors will appear when selling a structure. These are defined as actor types. Each unit should be specified with commas between. Each actor defined will only create one unit. With infantry body, the default attack sequence defines the sequence animation used when attacking. Idle sequences can be negated, so they do not have to be defined. This is as easy as defining negative idle sequences. However, this only needs to be done if there are idle sequences to remove. Testing in OpenRA can be made easier by enabling debug mode. You will need to restart the game each time you commit a change in game code. This is due to the game loading all assets upon game start, even missions and maps. The debug menu has many useful options. Instant build, give 20,000 credits, and disable visibility checks being the most useful. In the main menu, Extras Asset Browser can be used to view all assets in the game. In-game chat commands can also be used to enable debug modes. /give cache, /enable tech, /visibility, /instant build, /give cache all, /build anywhere, /all will work even if debug menu is not checked in single player, including text-only commands. /level up adds a specified number, 1 through 4, of level to selected actors. /kill kills the selected actors. /give cache 50,000 gives you 50,000 credits. /help will give you the full list of available commands. Commands can be entered even without debug enabled. Hitting the pause key allows you to enter text commands while the game is paused. Use Ctrl+P to capture a screenshot. These screenshots can be found in the %appdata %OpenRA folder under the mod's name. In the event of a crash, OpenRA will provide you with console and a general error code. Sometimes this will be specific to a certain line in a sequence or rule file. Not including add extension false to PNG sheet-based sequences. Crash. Actor name does not have a sequence named name, fixed by including add extension false. Defining frames and facings that exceed the number of available frames in a sequence. Crash. Sequence uses number amount of frames, but there is only number available, fixed by defining correct number of frames. Not giving a sequence negative facing. Actors' animations are played backwards, fixed by making facings negative. Content missing or not referred in packages. Crash log depends on what kind of content is missing, fixed by correcting spelling. Not properly aligning frames in a PNG sheet. Animations jitter and may not fit correctly, for example a turret sequence on an actor's body, fixed by fixing artwork. Not defining a queue for a unit. Actor will not show up in the parent actor's production list, fixed by defining a queue. Not using utility to process the PNG and YAML data together. .png sheet and .yaml need to be placed in engine folder, then use utility with command /png/sheet/import name of PNG, then cut and paste PNG into bits folder. YAML can be discarded. Indexing a color to an index used for flashing pixels. Simply recolor to another similar color, or create new palette and put exception to flashing lights. Inheriting twice. Crash. Inheritable was already inherited at line number, fixed by deleting one of the inherits definitions. Removing trait that does not exist. There are no elements with key name to remove, fixed by removing the negated trait. Forgetting trait requirements. Cost of valued trait has no value, fixed by defining cost for valued trait. Adding same trait twice results in overwrite of previous trait values, fixed by removing the extra value. Forgetting prefixes. Parent type will not be found, fixed by including the missing character. Letters/words casing issues. Possible crash. Referring to files with different casings will result in problems for Linux users and sometimes on Windows too, fixed by keeping all file names entirely lowercase. We highly recommend using GitHub to regularly back up your builds, as you can face difficult and basically untraceable crash logs. There is the potential to make even more mistakes along the way trying to figure out the original error. GitHub displays all the changes you have done line by line since the last build. That also displays a code of all your builds you have ever uploaded, making tracing out bugs easier. Having code publicly uploaded to GitHub also means more seasoned developers can look up exactly what is wrong. Consider joining the Patron Parade. In the next episode, we will cover the creation of custom factions.